started, right? Okay, so yesterday under SQL Server performance tuning, we discussed about very important things, that is performance killers. And out of those killers, we discussed only 3 killers. So objective was to let you know that from where performance tuning starts. It starts with the knowledge of performance killers. So we didn't cover all the performance killer yesterday, and the plan is also not to cover all. The objective is to cover all performance killers during the course, because when I'm going to cover each of the performance killer, right, at least it will take an hour, right? So it is not possible to cover all killers during demonstration class, but now you know at least what are the major performance killers that exist in SQL Server, and accordingly you can extend your knowledge, right, to deal with those killers, how to eliminate or remove those killers from SQL Server. Yesterday I shown, I presented this slides that what topics we are going to cover. Let us have a quick glimpse of the syllabus in doc format I should have. Let me show you firstly. Can you go on mute from where the sound is coming? Can you all please go on mute? Where is that? Here. So my screen is visible to all, right?
Right.
Okay.
Yes.
Okay, that's fine. So this entire syllabus is divided into multiple modules. I believe it is divided into 13 or 14 modules. 14 modules are there, right? Now, let us have just a glimpse of the topics that we are going to cover. So we will start from SQL Server Architecture, followed by the query optimizer role in SQL Server Architecture, then SQL Server and database level settings, right, for optimized performance. Then the performance tuning process. What is the performance tuning process? We will discuss what is performance baseline or baselining, how you can do that. So this has a different prospect. Performance baselining is having different prospect for developers and administrators that we will discuss. What you have to capture for the performance baseline as a DBA, and what you have to capture performance baseline as a developer. These are the things we will discuss under that. We talked about SQL Server performance killers, to deal with the performance of SQL Server. So yesterday we talked about these killers, and out of all the killers we discussed about only 2 killers in detail. The first was missing indexes, and the second was stale statistics or outdated statistics. Then we are going to enter into optimizing your database for the best performance or for the optimum performance. Right here it is the topic that I shown in the slide also yesterday, that is balancing under and over or over normalization. This is related to table design. Your tables must be in 3 enough, right? And it should not be over normalized, even it is 3 enough, or it should not be under normalized. Those are the things we will discuss under this. But we will have less emphasis on this. Rather, we will have emphasis around data integrity. So domain integrity, entity integrity, and referential integrity. These 3 integrities you will have to understand, and how you can implement these integrate, how you can implement these integrities in SQL Server while you are designing the tables using different constraints that you have. such as null, such as check, such as primary key, unique key, and then you have foreign key. So using the different constants, how you can implement these constants, that you have to understand. What are the index design best practices? Hello, hello, hello. Can you go on mute? Otherwise, I will mute you up. It's problematic. It's problematic. People are joining and then the background noise is coming. Next is your query design. This is very important part of performance tuning. Although you are an administrator, you must have very good knowledge on query designing part, right? Because nowadays questions are being asked from query designing part also in DBS interviews, like what is covering index, why you create it, what is lookup operator, right? What are the different kinds of lookup operator? What are different kinds of joins that is performed by SQL Server internally that is chosen by the optimizer as an operator, right? Uh, what are the different kinds of spooling that happens? Why it is bad, right? These are the different questions that that is asked in the interviews, right? So you must have very good knowledge on these also, right? So how to write good queries, right, within transactions, that you have to understand. There are multiple things related to query design. So someone asked me yesterday that is this training targeted for developers or database administrators? My answer was for both. This is my 9th batch, guys. I'm going to start from next Saturday. And very honestly, I am saying that almost most of the participants were administrators, right? So the ratio was 60-40. 40% people were from development side, and 60% people were from administration side. So performance degradation is ultimately going to be blamed on administrators, you know, because developers have a simple excuse that they say, if anybody is a developer, please don't mind, they say that they have written the very good code, they have written very good code, the code is completely optimized, right? So I don't have any clue why the code is not responding, right? So ultimately it is, blamed on the DBAs, that from database side, from the database server side, SQL server side, the query is not responding fast, right? But what the trend has now developed, that query tuning is now has become a very part and partial part for developers and for administrators as well. That's why people are interested to learn, and especially if you are facing interviews, right? Definitely you will be asked many questions. So many of my students have called me that, sir, they ask many questions from almost half of the questions from performance tuning, and they get benefited from this training, right? They crack the interview. So query design, it must not be ignored even by DVH. You have to understand this. This complete part, goes in the basket of DVH. This is server level settings. All are related to server level and configuration settings. But as a developer, you also must have knowledge of these settings so that you can cross-check with your DVH whether these settings have been optimized or not, right? If you have good understanding on these server level settings, you can even discuss with your DVH, right, how to optimize this. So this is all related to server level settings, you can see, right? Then I treat execution plan as a tool, right? So how the execution is, how the execution of a query is done, starting from the parsing by the parser, binding by the binder, a subcomponent of algebraizer, right? Then how it is optimized by the optimizer. So these all things we will discuss, right? What are the different components of execution plan that we will discuss? How the execution plans are trimmed out or flashed or flushed from the query from the plan cache by the lazy writer, that we will discuss, right? How you can analyze the execution of a plan cache. These are the things we will discuss. Execution plan reuse, ad hoc workload, how you can optimize a doc workload, why you should optimize a doc workload, right? What is forced parameterization, why you should not do forced parameterization. Forced parameterization can lead to the problem of bad parameter sniffing. What is bad parameter sniffing, right? Why you should not enable why you should not force the parameterization, right? That we will discuss. So this is all about that. These two statements we used yesterday to capture IO statistics and time statistics of the query. You saw that. Now we have detailed discussion on indexes, right? Is that index design recommendation, cluster indexes, store, non-cluster indexes. These are row store and column store indexes. Both supports cluster and non-cluster indexes. Then we will talk about cluster versus non-cluster indexes. What are the advanced index techniques? What is column stored index? When to use column stored index? These are the things there, right? And how to use that. Then index fragmentation, since excess fragmentation causes degradation in the performance of your query. So index fragmentation analysis, how you can do that. What are the different causes of fragmentation? These are the things we will discuss into that, right? And how you can, what is the importance of fill factor. Another parameter on while we are creating an index is pad index, right? So pad index and fill factor both are related with your fragmentation that exists in indexes, right? So these are the things we will discuss there. Then you have statistics. We discussed something about the statistics yesterday. Query store explain, yes. Query store is also there. So then you have a statistics analysis. I perhaps explained the statistics in very efficient manner yesterday, and those who have attended that session, right, it was really fruitful for them to have insight into the statistics, right, and how that statistics that is stored in the histogram structure of your statistics, right, is used by the optimizer. I put some focus and light on that, right? So those who have not attended yesterday's session, I shared the recording of yesterday's session. Go through that. You will have very clear understanding of statistics and its use in SQL Server by the optimizer, right, and in performance. Then again, we are talking about lookups, right? So one was lookup, that is bookmark lookup, and another was key lookup we saw yesterday, right? But we didn't especially talk about this. So we will talk about this during the course and how to resolve this lookup operator using covering index, right? Then you have three kinds of join used by the optimizer: hash join, merge join, and nested loop join. So in what cases, what joins are used by the optimizer in order to join two tables or two result sets or intermediate result sets, or you can say two sets of data, or how joined by hash join and merge join and nested loop join. And in order to that, you have to understand that when optimizer chooses what join operator to introduce in order to join two tables, right? So there is a concept of inner table, outer table. Another condition means that inner table must be indexed on the column on which you are joining. Outer table also must be indexed. In that case, and the data set is larger, it can go with merge join. If the outer table is small, inner table is large, right, and inner table is indexed, it can go with nested loop join. If both tables are not indexed, it can go. If both tables are not being joined on the index column, it can go with hash join. So this is just an overview I am giving here. So these are very important. And now if optimizer has not chosen the right join operator to join two tables, so in that case, you have to specify the join hint. So that we will discuss. Query recompilation is a good thing and bad thing too, right? So there are some benefits of query recompilation, but drawbacks are also that it consumes a lot of CPU time. So excessive recompilation of queries are not good, right? So which statement is causing recompilation that we can catch using extended event, right? And we can analyze the causes of recompilation. After that, we can troubleshoot that recompilation should not occur frequently, right? So for example, if you have an ad hoc query that is executing and its plan is creating over and again, so you can plan to convert your ad hoc query into a parameterized query, or you can even convert that ad hoc query into a stored procedure, right? There are many things to deal with. And then how you can avoid recompilation caused by statistics changes. So there are 3-4 main reasons due to which a query recompiles over and again. One of the reason is statistics changes, right? Another reason is uh, introduction of new indexes in the table, right? These are the two major reasons. Another reason may be introduction of new columns in the table, right? So these are the major reasons, and how you can avoid especially recompilation that is caused by statistics changes, right? That we will discuss. These two are the very important, I would say one concept of in-memory optimized table and another concept of natively compiled stored procedure. So where a high response time of queries are required, right? You can go with in-memory optimized table instead of disk-based table. So while creating the in-memory optimized table, what are the considerations, right? How you can create an in-memory optimized table, and before creating, what are different considerations that you must consider before designing the in-memory optimized table, that we will have to understand. And the best performance you can get from in-memory optimized table only when you are executing your DML statements, insert, delete, and update, inside a natively compiled stored procedure. I told you that natively compiled stored procedure is a procedure which is compiled by C++ compiler, Visual C++ compiler. It is not actually compiled by SQL Server compiler. That's why it is known as natively compiled stored procedure. So there are some keywords while you are creating a stored procedure. At that time, you have to define in order to make a stored procedure, simple stored procedure as a natively compiled stored procedure, and remaining whatever T-SQL statements you write in your stored procedure, you are allowed to write, no problem at all, right? But there are some restrictions among indexes. If you want to get the very high performance of your in-memory optimized table, you will have to go with hash indexes, right? Another kind of new index is there. So you have to go with hash indexes. That we will discuss. This is a very big topic that comes under transaction concurrency control in SQL Server. I discussed a little bit yesterday that it is achieved using two concepts in implementation. One is isolation level, three concepts actually. One is isolation level, another is locking, and the third is your row versioning, right? So isolation level, for isolation level, I talked yesterday. That is read uncommitted, read committed, repeatable read, and serializable. These four comes under pessimistic approach of transaction concurrency control, and they work on locks. They work on locking principle, right? So they work on shared, update, and exclusive lock, right? When you talk about locks, every lock that is occupied on a resource by a transaction, right? So a lock is occupied by a transaction via a session ID on a resource, right? You write a transaction or you execute a transaction from a session, right? So then that transaction requests or sends its intent to have a particular kind of request. Say you are sending an update, you are executing an update transaction. So update transaction will send an update intent lock request to the lock manager on a particular resource. That resource may be a a single row, a range of row, a table, right? or or a page or some pages, right? Or even a schema or a database, right? So that comes under log granularity. Log granularity on the lowest level starts from row, then go to range of rows, then on pages, then on extents, then on table, then on a schema, then finally on database level. So this is a big topic, and if you have very good understanding on this, right, you will be able to resolve the blocking and deadlocking problem by yourself, right? So behind that, you must have very good understanding on these all things. So deadlock analysis, usually to see the deadlock graph, we use profiler. Extended event does not support, using extended event, you can capture deadlocking, but in textual format or in XML format, not in graph format. So if you want to capture the deadlock in graphical format, right, you will have to use profiler in that case. But we can automate capturing of deadlock, using extended event as well, and send the mail to the administrators. Then someone asked about query store. You can see query store here. Is it here? Yes. So these are the different tools. Those are used during performance tuning in SQL Server. The one that I started from the demo itself, that is query plan. Another is SQL profiler. Next is extended event. Then you have plan guide. So plan guide is basically used when you don't have you don't have access on the code of the store procedure. I mean that if your store procedure is encrypted, you cannot tune the code. So in that case, you can create a plan guide to execute particular statement of that stored procedure, right, with a particular hint. You can specify plan guide. So I will show you how we can do that. Then you have query store. So query store is a wonderful tool that was introduced in SQL Server 2016. And the specialty of query store is that without writing very complex queries or long queries, right, you are able to see your queries which performance have degraded in last 7 days, 15 days, right, or in last for 2 hours, or in 30 days, right? So the query whose performance has degraded, the queries which performance have been degraded, you can see those queries. And then you can start tuning those queries, or you can try to find out the reason behind that. That is the first thing. You can get a list of or a report of regressed queries. Second, you can get a list of queries by the varying time of execution, right? Say, for example, if 100 users are executing a store procedure, right? And say some users get the result in 1 minute, some gets in 2 minutes, some gets in 3 minutes, some gets in 7 minutes, right? Again, some gets again. The first user got its result in 3 minutes, and next time he's executing, he's getting his result in 7 minutes, right? So that query is having a variance time, right? That query is having a variance in execution time. This report is provided by Query Store. You can see that, right? After that, Query Store is the only tool in SQL Server that is available in graphical user interface term, where it also shows you the plan IDs, every plan that is generated by SQL Server. If that is a unique plan, it will have a unique plan ID, right? So it gives you the list of plan IDs using which a query was executed, right? And it also gives you the information that how much time query executed using a particular plan that is associated with a particular plan ID, right? So if my query executed by 3 in different executions, say I executed my query 10 times, and 3 plans were generated for any reason, right? I'm not talking about the regions right now. For any reason, my query executed in with 3 plans. So 3 plans IDs are there. Now you can go to the each plan in GUI way, and you can see that using which plan ID or using which plan my query executed in list time. And you can force that query to execute always with the plan ID using which my query executed with the list time. So query store has multiple features. It all on you, that how you are using it. So it's a wonderful tool for performance analysis, especially and tuning. The final module, we will talk about troubleshooting high CPU utilization issue, high memory issue, high IO issue, and then we will talk about troubleshooting temp DB space issue and contention issue. So these are the things we are going to, these are the topics we are going to discuss under this entire course. The course consists of 14 modules you saw. The mail that I sent yesterday, perhaps you all received that. Let me come to the mail here. This was the mail here. I mentioned these points, right? So just want to iterate this. What is written here? Batch starts from Saturday, 7th November. Class mode is online. Duration is of 6 weekends, but you can think that it will cover in 7 weekends, right? Maybe that if any of the day I'm not available, right, then in that case, we can go to 6 to 8 weekends, not a problem. So anyway, you will have, I can ensure you that you will have more than 12 classes. So classes are on every Saturday and Sunday, 3 hours, right? Class timing is 7 p.m. to 10 p.m., right? IST time. This is Indian Standard Time, and it should be 9:30 a.m. to 12:30 p.m. in EST. Course fee is 12,000 rupees, and it has to be paid in INR. It has to be paid as a down payment before 7th of November. Then only I will be able to send invite to you. If you want to pay in US dollar, you will have to pay 180 US dollars, right? Class recording will be shared for download after each class. Like I am recording here. When the class will be finished, at least it will take an hour to become it available for me for sharing. So after that, I will share the recording. Whatever document, for example, today I will discuss about troubleshooting high CPU utilization issues. So I have this document, the same document I will use in the training, right? This document will be shared with you. So after each class, whatever documents we will use, that will be shared with you, right? Remember, only 10 seats are there. I do not prefer to have, I will have more than 10 students in a batch because it's tough to manage, right? So I limited the number of seats only to 10, and admission will be taken on the first comes, first serve basis. So if these 10 seats will be filled, not fulfilled, these 10 seats will be filled, right? After that, I will be not able to entertain you in this batch. And if you want to take admission in the course, just reply me over my mail, right? Or you can ping me, or you can call me on this number. This is my WhatsApp number also, right? So this just I want to bring in your notice here. Any questions so far? Someone pinged something? Okay, we'll do that. What's your name? What do you pronounce it? Saudat. Saodat. How do you pronounce your name? Hello. Okay. Okay, guys. So you can see that troubleshooting CPU performance issue usually from where people start. Usually, people start DBAs start by checking the privilege time under the processor object, right, and percent user time under the privilege object. People start from there. That is a good approach. You should start from there. Then you come to your weights, right, using the DMV, waiting task, weight stats. You start to analyze your weights, right? That is what I have seen. Even most of the people start to troubleshoot the issue by just by analyzing what I was trying to say. Just by gathering the queries. What are my queries which are CPU intensive? They are starting from there, right? So that is good. That is good. That you should do once you know that your server level settings are completely optimized, right? Your statistics is completely updated. Your index is not fragmented. If you know these three things, you are sure that these three things are fine at my server. You should go ahead and start capturing the queries by your maximum CPU time or by the worker time, right? You go ahead and start capturing your queries. That is fine. And after that, you try to troubleshoot your query, right? But what should be the ideal approach from where you have to start troubleshooting CPU, right? I would like to start from there, from the scratch. But before I start to talk about troubleshooting CPU, you have to understand the concept behind that, because when I will enter into weights, so I will talk about a weight, say I will talk about a weight SOS scheduler yield, or I will talk about a weight, say thread pool, right? So if you don't have understanding of a thread, you cannot understand thread pool, and you cannot understand thread pool starvation, right? So if you understand the term thread pool starvation, and now again thread pool starvation is related to workers. Workers are related to scheduler. Scheduler is related to Sql Os, right? So everything is interrelated here. Once you understand these concepts, right, then you have a clear understanding what you are diagnosing, what you are analyzing, right, and what should be your next step to troubleshoot the issue, right? If you don't have these knowledge, then what you will do, and most of the people do, that what is the standard practice that has been established in an environment that people are following, right? So that you should do. I'm not denying whatever standard has been established in your environment, right? You should follow. But at the same time, you must have very good understanding on these all concepts so that you can also suggest anything additional, or you can also, establish a new standard to, have the troubleshooting way in very standard format, right? In very standard way, your troubleshooting in your environment should go, right? So as I told you that when I will talk about weights, say for example, I'm talking about, uh, you know, thread pool weight. So thread pool weight comes due to thread pool starvation. You have to understand thread pool starvation. Thread pool starvation is related to workers. Workers are related to schedulers, and scheduler is related to Sql Os. So let us start to understand these all things from very basic, right? Let us try to understand this from the concept of SQL OS itself, right? Can anybody tell me that what SQL OS is and what it does, why it was introduced in SQL Server architecture? Oh, a lot of background noise is there. Uh, from where this noise is coming. Okay. Are you people able to speak?
I think yes, Neeraj.
Okay. The sound is lower from my side or your side?
Neeraj, you are audible.
Okay, good. So I asked one question. What is SQL OS? What it does? Why it was introduced in SQL Server? Think about it. I will be back in a second, in 10 seconds or 20 seconds. It's time for your turn. I'm waiting for answers. Hi, Brooke. I can see you have joined.
Yeah, thank you very much.
The one thing is, Neeraj, it manages the operating system resources.
Operating system resources. So, okay, operating system. Most of the times nowadays we can also host SQL Server on Linux. That is fine, right? Most of the SQL Server are still on Windows world. They are on Windows Server, right? So Windows operating system itself is able to manage its resources, right? You can say that in
In order
order
to
to,
SQL database engine
Hmm,
resources.
okay, that's fine. Uh, to whom I was talking?
This is Avinash.
Avinash. Okay. How many number of experience you have, Avinash?
I have 7+ years of experience.
Okay, that's fine. Okay. Anyone want to explain it? Okay. So let's have a little bit discussion about the SQL Server architecture first. So the first component is your protocol layer. My question is here, why a protocol layer is necessary here in the architecture, right? The answer is very simple. To have communication between SQL Server and clients, a communication protocol is needed, right? So that's why a protocol layer exists. SQL Server supports basically three protocols. One is your shared memory, another is named pipes, and third one is your TCP/IP, right? So shared memory protocol is used by SQL Server to have communication between client and SQL Server when both are hosted on same machine, I would say. It may be VM, it may be your physical machine, right? When SQL Server database engine, I mean that SQL Server and the client exist within a local area network, right? Then communication between client and SQL Server happens using named pipe protocols. And when client and SQL Server are far apart, they are beyond the local area network, they are over internet, communication between client and SQL Server happens using TCP/IP protocol. isn't it? So for example, my SQL Server is hosted here, and SQL Management Studio is my client here, right? SQL Server Management Studio is my client. You have many clients, SQL Server Management Studio, you have Azure SQL Data Studio, right? Azure SQL Studio. One more new tool is there. These are your client tools. And when you connect to an application, when you connect to the database using an application, your application itself become a client, right? So communication between SQL Server and client always happens using a certain protocol that I told you. So my SQL Server and my SQL Server Management Studio both are hosted on my laptop. This is my physical machine. So I can show you that my, okay. So I think that I am connected to Azure instance here that was targeted for different batch. Let me connect to the local instance. So new query. Select a star from just a minute. Sorry. Select a star from sys dot dm underscore exec underscore connections. Execute it. See here. The sessions that I have established, right, to this instance, all are connected using shared memory protocol because my client and SQL Server both exist on same server, on same machine, right? On same physical server or on same machine. So that is the case here. That's why I told you. So we are clear with protocol layer, right? Any question here? Next component is your query engine, and query engine is also known as query processor, right? So it consists of many subcomponents. The components that make query processor or query engine is your parser, followed by your algebraizer. There is a subcomponent in algebraizer that is known as binder or name resolver. Then you have another component after algebraizer is query optimizer. And finally, you have query executor, right? So the task of this query processor engine is to accept queries and pass them, compile them, generate the plan, and execute them, right? Query processor executes the plan, and it always works with a storage engine, right? So there are many responsibilities of a storage engine, but mainly a storage engine is responsible for providing access methods so that data from tables can be accessed, right? Three access methods a storage engine provides that I discussed yesterday too. One is table scan, another is index scan, and third is your index seek. Just a second. So a storage engine provides three access methods to the optimizer while it is generating the plan in order to access the records. What I'm trying to say you, try to understand here. For example, let us change the database context here and write a simple query. Say select a star from sales order detail, right? So So see here, we are executing this, but behind the scene, this query will be parsed, compiled, a plan will be generated, and then after that, query executor will execute it, right? Let us capture the plan for this query. Query include actual execution plan, execute it. Now, come to the execution plan, you see that what is the operator, physical operator being used in order to access data from sales order detail table. We have written here sales order detail, but rather getting data from the table, it's getting data from its clustered index, right? The clustered index can be seen under object section here. That is PK underscore sales order ID, sales order detail ID that we created yesterday, right? So from cluster index, the access method to access the data that is being used is index cluster index scan. So index scan is the access method that is being used by the optimizer through the operator cluster index scan in order to get data from the sales order detail table. Got it? Meanwhile, if I will put some condition here where sales order ID something, so you will see that instead of cluster index scan, cluster index seek operator is being used. So that defines the access method. Okay. So the first task of a storage engine is to provide an access method to the optimizer for retrieving the data from the table. The second is page allocation, right? A storage engine allocates the pages in terms of extents to databases. So at 2 times, a storage allocation for pages are done, right? For example, let us create or let us check for the data file and log file for a sample database here. Come to the files. You can see the first thing that you specify for initial size, right? So this initial size is assigned to a database while you create a database. When you create a database, at that time, whatever the size you specify as the initial size, that a space is allocated to the database in terms of extents. So storage allocation is one of the major tasks of a storage engine. And when your database auto grows, if you have enabled auto growth, right? So when your database auto grows, at that time also, whatever MBs you have specified, that is converted into extents, and those extents are assigned to the database by the storage engine. That is another task. So apart from that, there are major tasks, many tasks, but these two are the major tasks. Anyway, we have to focus on Sql Os. So Sql Os is a virtual operating system that was introduced in Sql Server 2005, and starting from Sql 2005, it continued. It is available in 2008, 12, 14, 16, 17, 19 in all versions, right? So if anybody asks what is Sql Os, Sql Os is a major component of Sql Server. It was introduced in Sql Server 2005, and majorly it was introduced to have Sql Server own scheduler. This scheduler is not a job scheduler. This scheduler is a thread scheduler. It schedules threads, right? So what is a thread, right? I executed this command. This got executed, right? But how it got executed? In order to execute this command, it needs the CPU time. Who assigns the CPU time to this query, right? The scheduler assigns. How many schedulers I have in SQL Server? I shown you yesterday using the command select a star from sys.dm underscore exec, not exec, dm os underscore schedulers. These are available under SQL OS. You can see dm os. OS means SQL OS, right? So schedulers are part of SQL OS. I have 4 processors on my system. I can show you MS Info 32 system information. There are 4 logical procedures I have on my server. You can see 2 cores, 4 logical procedures. So I will have 4 user settlers. Let us execute it. You can see settler ID 0, 1, 2, 3. 4 user settlers are there. All user settlers are always online, visible and online. Rest are system settlers, right? They all are tied with some CPUs, right? But their IDs start with some random numbers, not in serial fashion, 1, 0, 2, and 3. So I have 4 user settlers. They are tied with 4 CPUs, right? For example, settler ID 0 is tied with CPU ID 0. Settler ID 1 is tied with settler CPU ID 1. Likewise, settler ID 3 is tied with CPU ID 3. These are visible and online. These are user settlers, right? So rest of the settlers that you see are hidden and online. They are not visible. But one of the settler you see here as DAC. This is for dedicated administration connection. So this is not having a number like 1, 2, 3, 4, 5, but it is also a scheduler. This is reserved for dedicated administration connection. Usually you use when your SQL Server CPU utilization is very high, right? Or memory utilization is very high and you are unable to connect using your Management Studio simple interface. At that time, you use the DAC connection, DAC connection. So these are the schedulers. Now, what happens? I executed this query. So a plan is generated for this query, right? On the basis of the plan, whether a serial plan has been generated or a parallel plan has been generated for this query, right? Threads will be decided. Since it is a very simple query, right? A serial plan will be generated for this query. If your query is a multi-part query and that crosses the cost of your cost of the that crosses the boundary of the cost that you have defined for your cost threshold for parallelism, then a parallel plan will be generated by the optimizer for that query, and that parallel plan will have multiple parts will be divided into multiple threads, right? So those threads, now your query is converted into threads, right? On the basis of the serial plan or the parallel plan. If it is a serial plan, it will be a single threaded query. If it is a multi-threaded, if it is a parallel plan, it will be a multi-threaded query. So considering it's a serial, a serial plan is generated, and it's a single threaded query, right? So how this thread, this query as a thread will execute, right? So it will go into, it will go under a scheduler, right? The task of scheduler is to assign a worker for that user query, user thread, and execute it. But who will execute it? CPU will execute it. So task of scheduler is also to assign a worker and assign a CPU quantum. A CPU quantum is nothing but a time of 4 millisecond slot. So scheduler assigns a 4 ms slot as known as quantum to a thread for its execution, right? So let us come here, see if I have depicted something or not. It will be easier for you to understand then. Okay. So say for example, that was the query, or this is my query, right? This is my update query where I'm updating the unit price column value. So considering that it's a serial plan, a single thread was generated for this, right? It came under the scheduler. Now every scheduler have a waiter list. So first of all, this thread will go into the waiter list of that scheduler, where it is waiting for the assignment of a worker by the scheduler, right? Where it is waiting for the assignment of a worker or a worker thread, we can say, Your queries are user threads, right? So every user thread has to execute under a worker thread or under a worker, you can say. So a scheduler have multiple workers, right? Scheduler is the master and workers are slaves. A scheduler always have multiple workers. I told you yesterday how many workers I have in SQL Server. I can check that using the command select star from sys.dm dm underscore os underscore that was perhaps sysinfo, right? Sysinfo. So let us execute it. How many workers you have? Max worker count column should be there. Max worker count, it's 512. So if you have, and scheduler count is 4. So you have 4 processors, right? You have 4 schedulers. Scheduler count is 4. You have 4 processors, so you have 4 schedulers. And for 4 schedulers, you have 512 workers, right? It means that for each worker, you have 128 workers available at any time, right? Then I talked about the quantum, that scheduler assigns a quantum of 4 ms, right? OS quantum. So a quantum of 4 ms is assigned to a thread by the scheduler for its execution. Let us come back now. So here, scheduler, the thread came into the first the thread comes into the weighted list of a scheduler, right? Now here it is waiting for the assignment of a worker. A worker is assigned. When a worker is assigned, then it moves from the weighted list of the scheduler to its runnable queue. This is known as weighted list or weighted queue, and this is known as runnable queue. So it moves from weighted list to runnable queue. The worker is assigned, right? Now the worker is assigned. Here now it is waiting for the assignment of a quantum, that is the CPU time of 4 ms. So when the 4 ms time of or the quantum of CPU is assigned to the thread, right, then it enters into running state. Your thread start executing here. Your query starts executing here, right? Your query starts. So it will start for 4 ms. There are 2 possibilities here now. When the query is started, whatever resources it needs, those are available. So query will execute for 4 ms. When its execution will be finished, again, it will come back to its runnable state. Again, here it is waiting for the assignment of the CPU time. Again, that will be assigned. The quantum will be assigned. Again, it will come into running state. It will go on. But what is the second probability? Second probability is that the thread may have to wait for a resource to be free. Let us try to understand it through these 2 examples. This is my transaction that I am executing through session ID 62, and this is my transaction that I am executing through session ID 64. Both are trying to update the same table, same column, but with a different value, right? For the same sales order ID. It means that these 2 queries are trying to update same number of rows because the condition is same here, right? 3, 4, 5, 6, 7, 8 sales order ID. So there may be 4 rows or 400 rows, right? I don't know how many rows are there meeting this condition. Just assume that there are 50 rows, or just assume that there are 500 rows. Those are being updated, right? So I executed this first. This was executing under a scheduler, right? And when it started executing, right? So what it will do, it's an update statement, right? So first of all, say 500 rows it is trying to update for the unit price column value. 500 rows are there on, say, on 5 pages. So page level locks have been occupied, right? Page level locks have been occupied on 5 pages and modification is going on. So those pages are exclusively locked. These pages are exclusively locked. 5 pages are exclusively locked. Now, this transaction cannot, this transaction 64 transaction, while this transaction that is executing under session ID 62 has exclusively locked those 5 pages of the sales order detail table, right? Will take some time, say for 20 seconds or 30 seconds to update, right? So while it is updating, it has exclusively logged those 5 pages of the table. This transaction will have to wait for those 5 pages to be free. Those 5 pages will be free from exclusive lock only when this transaction will complete. When this transaction will complete, it will commit, right? And the exclusive lock that it has occupied on those 5 pages, that will be freed. So when that will be free, the exclusive lock from those pages will be free. After that, this transaction will proceed. So now see here, while my this query or this thread is waiting for this resource, the 5 pages to be free, right? It was assigned a time of 4 ms to execute, but it is waiting for the resource to be free. So voluntarily, this thread will put itself into suspended state. What does it mean that voluntarily when it will put into suspended state? It means that it is freeing up its 4 ms of time, which was assigned by the scheduler to the thread, so that that 4 ms of time of CPU time can be utilized by other thread for its execution, right? This settling algorithm is known as cooperative settling algorithm. And this is exactly used by SQL Server scheduler. And the opposite is your preemptive settling algorithm, which is used by Windows operating system. And before SQL Server 2005, SQL Server did not have its own SQL OS. So it did not have its own scheduling algorithm. That's why threads were set, SQL queries threads were scheduled using Windows scheduler, using preemptive settling algorithm, where what happens that even if 4 ms quantum is assigned to a thread, it enters into running a state, and even though it is waiting for any resource to be free, right, it will not relinquish, or it will not empty, it will not free up its 4 ms of time, right? Rather, it will keep idle. So this is the vestige of CPU capability. This is the vestige of CPU time, right? So that algorithm is known as preemptive settling algorithm. If you are going for higher interview, right, people may ask you question that what is SQL OS, what is settler, what kind of settling algorithm is implemented in SQL Server, how SQL Server cooperative settling algorithm is different than preemptive settling algorithm, why Microsoft felt a need to introduce, you know, cooperating settling algorithm in SQL OS in place of preemptive settling algorithm. Such questions may be asked if you are going for L3 position interview or higher. So any question here, any doubt?
Hey Neeraj, Setu here.
Yes, tell me.
Yeah, I just joined like a little late, so
No
I mean,
problem.
you explained about quantum. So can you explain? I mean, talk about it, please.
Perhaps you joined somewhat late, right?
Yeah, because I was using this DMV, but I never like considered that as some key like measurement actually.
Uh, Someone put a question, sometime query waiting is more than 12 hours in suspended state. Yes, it's performance issue, right? It means that the resource which your query is looking for is not free. It is waiting for the resource, right? That's why it is in suspended state. And it's very bad. You might have a big performance issue in this case. Isn't it, Tulsi? Yes, it's a very bad sign. You asked about quantum, right? So quantum is nothing. I explained that every query that you execute is represented as finally as a thread to the scheduler. So when I will execute this query, a plan will be generated. If the query is not complex, and if it is not crossing the boundary of what was that? Uh, Cross threshold for parallelism, right? Threshold for parallelism. If it does not crosses that threshold, don't kill any query, right? Or any thread without user approval. Once you know that from which user this query is coming, right? Don't kill that. It can have a big impact. You will be in the question, right? So always kill initiation after the user approval. That is a good practice. So when the plan is generated, that plan can be serial or that plan can be parallel. Anyway, if it is a serial plan, the query will be a single thread. The query will be represented to the scheduler as a single threaded query. If your query if a parallel plan was generated for your query, then that query will be represented as a multi-threaded query to the scheduler. Now the scheduler assigns a worker first to that user thread. After that, that thread comes into the waiter list of the query. Here was the depiction waiter list or the waiter queue of the scheduler. Then here it is waiting for the assignment of worker by the scheduler, right? So when the worker is assigned, then your thread moves into runnable state. In runnable state, it is waiting for the assignment of the quantum. A quantum is of 4 ms, that is 4 millisecond time of the CPU. Then when the 4 ms milli time, ms of CPU time is assigned to the thread, then it starts running, right? And the possibility is that if resources which are required by the query is available, it will run to its entirety for 4 ms. When that is finished, again, it will come back to its runnable queue, right? And again, it is waiting for its quantum allocation or the CPU time allocation of 4 ms that is assigned again. Again, it will execute. This will go until the thread is finished. The execution of thread is finished. But sometimes the thread may have to wait on a resource to be free. I explained through this example. I'm not known whether you were there when I was explaining about this example.
I am there here.
Yeah. So it may go into suspended state, right? And when it will go into suspended state, then after suspended state, again, it will come into runnable queue. Here again, it is waiting for the CPU assignment time when that will be assigned, right? Again, it will come here. Okay. Again, if resource is available, then it will execute. If not, again, it will put into suspended state. So that happens in case of cooperative settling algorithm. Exactly that algorithm is implemented by SQL Server in Sql Os by Microsoft. Right?
Yeah, thanks, Neeraj. And I have, often like we are running backups, like a full backup, differential backups for like terabytes of database. And I see that it is creating a lot of SPIDs and it is going from running, runnable, suspended. So
Yeah, that is natural. That is natural. So
that is natural.
that is natural. If I come here and just I execute a command, select a star from the very basic command we have been using from early days, leave it exec. Just use sys.processes, sys.sysprocesses, where SPID is greater than say 51, then you will see multiple sessions are there. And under each session, you will see or the status for each session. You will see the status. What is the status of each session? So most of the sessions are here in sleeping state. They are idle. They are not executing. They have already executed. They are in sleeping state. One process is background process here. One process I can see in runnable state. Another is in sleeping state. So the interesting thing is here. Many of the people think that this is the status of your session, right? No, this is not the status of your session. This is the status of your threads. You can see multiple entry for the same session ID here, right? Have you noticed? You can see multiple entries. For example, you can see multiple entries for session ID 56, 56, 56, right? So the query that you have executed under session ID 56 contains multiple threads, right? And those threads are executing under session ID 56. And the status that you see here, those are the status of threads, not of sessions, right? Those are the status of threads. So it's natural that the status will change, right? So you will see the status that status is sometimes it is running, then you will see in sleeping, then you will see in runnable, right? So if it is changing, that's fine, but it should not be there for the maximum time in the suspended state. If it is in the suspended state, it means that the query is looking for such a resource which is not available, which may be exclusively locked by some other thread or some other query, right? So it's natural. The status will change, keep on changing, but any thread status should not be for a longer in suspended state, or should not be always in suspended state. If it is in suspended state, right, it means that the resource your query is looking for or the thread is looking for is not available. So definitely it's an issue of performance.
And Neeraj, when the status is in sleeping, so can we say that it is in the
Sorry?
waited list?
Sorry?
When the status is in sleeping,
Mm-hmm.
so can we say that it is in the waited list, that is in the queue?
No. Sleeping means that your query is already executed.
It is already completed.
Yeah, it is already completed. It's not in sleeping state. It is already completed. It's not in waiter list.
Okay. And also, when it comes to suspended status, can we also
Your
consider?
sound is very low.
How about now?
Better?
Okay. When the query is in suspended state, can we also consider it as it's completed half of it? Like, say, for example.
You cannot assume. You cannot assume.
Okay. No,
On the
I am just
basis,
checking about the possibility of it. So as you shown as an example, when you're updating a statement, it started, but it is waiting for another SPID to complete because it was already exclusive lock was acquired on other session.
right?
So in the same way, within the transaction, it has executed some part of it. And in order to execute second part of it on the same transaction, it has to wait for another resource to be released.
Yes, that's correct.
So even that time also, the session can get
Go
into
into
suspended mode.
suspended state. Yes.
Okay.
It can. It can go.
Okay. Yeah, that's all. So in that case, we can say that any particular session is completed half of it. So even during that time also, any session can go to suspended status.
No, you cannot predict that half of the work has been done. You cannot predict.
Okay.
On the basis of this, you cannot predict.
Okay.
Right, guys. So I think that now you all have very clear concept of Sql Os, schedulers, workers, scheduling algorithm, cooperative and preemptive scheduling algorithm, right? Let us go ahead and now discuss the two things. related to CPU, high CPU utilization issue, max degree of parallelism and cost threshold of parallelism, how these two are interrelated. So I will be back in 2 minutes, and then I will put focus on this. Okay, so let us start to understand these two, max degree of parallelism and cost threshold of parallelism. I believe most of you know, but let us have some focus on this. Go to the server properties page, come to advanced section, and here we do have max degree of parallelism and cost threshold of parallelism setting. These two are related with server level configuration or server level parameters, we say, right? So by default, the max degree of parallelism is always set to 0, right? If we set to 1, what does it mean? Can anybody tell me?
It's running values, right?
No. If I set,
So,
set
Neeraj,
max,
sorry to interrupt you. Yeah, whenever we have like, multiple processors, then we can use it.
no.
I mean,
But
that thread will, execute with like all processor.
no. So my simple ask is, by default, it was 0. 0 means all. I have 4 processors. It means that my queries, if required, can execute with 4 processors. If required, can execute with 2 processors. If required, can execute with 3 processors. I mean that I have allowed queries execution to involve all processors, right? When that will be done, I will talk later on. Let's try to make it simple. But if I make it 1, it means that I am disabling the parallel execution of query. You got it? I am disabling parallel execution of a query. It means that if a query plan has been generated, right? So that query plan will be always a serial plan, even though it goes beyond cost threshold for parallelism value. So by default, the cost threshold for parallelism value is 5, which is considered to be low, right? It should be in between 20 to 30 for your best performance in your environment. 20 to 30 you should set, right? So 20 to 30 is considered to be a optimum value for cost threshold for parallelism, because when the cost of your all operators that appear in your execution plan, I will show you, the total of cost of all operator when goes beyond 5, your query will qualify for parallel plan generation. And when the parallel plan will be generated, ultimately that query will be represented as parallel threads, multiple threads. And those threads will be assigned to different settlers. And those settlers are tied with different CPUs. It means that those, say, for example, my query is ultimately divided into 4 threads. So 4 threads will execute in parallel, right? At the same time, they will start to execute. So in that case, my query execution time will be leisure. But we should not encourage this idea always. We should not allow all queries to qualify for parallel execution. We should not allow all queries plan generation to be parallel. So for that, we control this value. We optimize this value, right? We optimize that if the cost threshold for parallelism for any query goes beyond 20 or 25 or 30, then only its parallel plan should be generated. That is what the cost threshold of parallelism says, right? Query optimizer of SQL Server is a cost-based optimizer. How we are deciding the cost? Let us see this. So let us focus on this topic for some time. You will have very clear idea. For example, let me put some better query here. Query consists of some joins. I will pick that. It's a simple query, just joining two tables. Just change the database context here. I will start a recording, right? Yes. So just go ahead and execute this query, but before executing, capture its plan. Include actual execution plan. We have to select here. Execute it. The query got executed. Here we have the execution plan. So your query optimizer of SQL Server is a cost-based optimizer. Cost of every operator is calculated in terms of CPU cost, IO cost, and subtree cost. If you come here, the major cost that we consider while we are calculating the cost of a plan or a query is your estimated subtree cost, something like that. You have here build in the first section. If you see in the between uh, in the mid, you will see estimated subtree cost. You have estimated CPU cost, right? You have estimated IO cost, you have estimated operator cost, you have estimated subtree cost, right? So this subtree term comes from the algebraizer. Say for example, I executed this query. So first of all, it is parsed by the parser. Parser will generate a parse tree. It will hand over to algebraizer. Algebraizer will convert that parse tree into query tree. So a query tree consists of many sub branches. Those are known as subtree, right? That is internal representation of relational algebra. So from there, that concept comes of subtree. So we majorly consider the cost of subtree while we are calculating the total cost of any plan. So estimated subtree cost here, you can see it's 0.003, something like that. Then you have the cost for this also, estimated subtree cost as 0.012753. You have the estimated subtree cost for also 0.3, right? So if you calculate these all costs, right, and if it goes beyond 5, then only this query will qualify for parallel plan generation. Otherwise, the serial plan will be generated, right? So your complex queries should only qualify for parallel plan generation. Queries that you have written and where you are joining, say, 5 tables, 10 tables, 8 tables, right? Multiple conditions are there. You have put order by clause, you have put having clause, you have put where clause, right? You are joining your tables. So if it is a very complex one, then only it should qualify for parallel plan generation. And that's why you should optimize this value, right? That I have shown you. The default cost threshold for parallelism value is set to 5 by default. It should be greater than 20 and in between 30. So 25 and 30, both are considered a good value for cost threshold parallelism in your production environment, right? What I was telling that if I define this max degree of parallelism value as 1, it means that completely I am disabling parallel execution of the queries. Every query will be executed as a single threaded query that we will execute, whether it is simple or a complex one. it will be a single threaded query, and a single threaded query is always executed by a single CPU under a single scheduler. You got it? So there are two exceptions from the world standard. One is your SharePoint SQL databases. If your SharePoint databases are hosted on SQL Server, Microsoft recommends to set max stop value to 1, because the queries that usually people fire against SharePoint databases are written in such a way that they provide best performance when the max stop is set to 1. Another is your SAP databases. If your SAP databases are hosted on SQL Server, the SAP team also recommends to set the max degree of parallelism to 1. Apart from that, there may be some application vendors who are suggesting to set max degree of parallelism to set to 1. So the conclusion is here, never set it to 1 until and unless you have a recommendation from the application vendor. The first thing. Second thing, never change its value. You should not change its value, leave it to 0. Allow SQL Server to execute queries as per in parallel fashion as per the need.
Yeah, Neeraj, like in most of the companies, like, I mean, we will go with 8, 16, some kind of a value based on the Microsoft recommendations. I mean, if you have like a 24 CPU, then we might going to 16, sometime 8. And is that a myth then?
I am coming to that. I have not yet discussed that part, right? So there are some standard method to calculate what should be the value here. So one approach, I'm talking about the performance tuning approach right now. One approach is you should not play with this setting until and unless you do not experience any high CPU utilization issue, right? Or you do not experience any slowness in your query. Don't play with this setting. This is the performance tuning approach, right? The second thing is to establish a standard for setting the value of max stop in your environment, right? So for that, you have to follow the best practices that is recommended by Microsoft, right? So I'm not denying what you are saying, but that is a practice that you have to follow. So what is that practice? Let us discuss that. This is the recommendation from Microsoft, especially for SQL Server 2016. And moreover, it is applicable from 12 itself, right? So here the term is NUMA node. Let us try to understand this. How many of you know about NUMA node? You come to procedures here, expand it. You see here, I have a single NUMA node. What does it mean? And under this NUMA node, I have 4 procedures, right? So NUMA and UMA, these two are the CPU architecture, right? So I'm not talking about those architecture right now. Here, simply understand that I have a single socket on which CPU is hosted. 2 cores are hosted on a single socket, and then again using the hyper threading, those 2 cores are logically divided into 2 CPUs. So ultimately I have 4 logical processors. So NUMA node simply says that you have a socket. I have a single socket. If you see NUMA node 0, NUMA node 2, NUMA node 1, it means that you have 2 NUMA nodes, right? It means that you have 2 sockets. So more sockets you will have, more costly your VM will be. I think that one of the guy put one question in one group that while I'm ordering my VM with more sockets, the cost is increasing. So I told him, yes, more the sockets you will have, more NUMA nodes you will have, more NUMA nodes you will have, more performance gain you will have. What is the best practice? That under each NUMA node, it means that under each socket, you should not have more than 8 processors, right? You should not even have more than 8 logical processors. You will see in many environment that under a single NUMA node, 16 processors are there, right? So those 16 processors comes under a single hard NUMA node. Your socket refers to a hard NUMA node. Starting from SQL Server 2016, you can create soft NUMA node also in SQL Server. So if machine has already been provisioned, right, and now that NUMA node cannot be replaced, right? So what you can do, you can create soft NUMA nodes. So for example, I have 16 NUMA nodes under 16 processors under a single NUMA node. What I can do, I can create 2 soft NUMA nodes, and I can put my 8 processors under 2 different soft NUMA nodes for best performance. That I can do. So I think that now you people are clear with NUMA node. So this is the recommendation from Microsoft. This is not my recommendation. So if you have a server with single NUMA node and you have say 4 or 8 logical processors, right? Keep the max top value at or below of the logical processors, right? It means that if I have 4, I can either set my max top value to 2 or 4. But the best practice is if you have 4 processors, you have a virtual machine, then go with 2, not with 4. If you have a physical server, it's fine. You go with all processors. So single NUMA node, say I have 8 processors here. I will go with maxed out value 8. But if I have a VM virtual machine, most of the times we do have virtual machines only, right? So go with half of the total number of processors. That would be better, 4. And even my experience is here, you go with 2. Start to tune maxed out with 2, and then watch for the seals packet value, watch for the thread pool value, watch for the SOS scheduler yield value. I will tell you how you can analyze those things, right? So this is what Microsoft recommends, that if you have another recommendation is server with single NUMA node greater than 8 logical processors. First of all, I would say that it's not recommended. It's not a recommendation, but still if you have a NUMA node, single NUMA node, but you have say 16 processors or 12 processors, right? In that case, you should keep your maxed off value at 8. But again, my recommendation is not go with 8, start with 4. Even if you have 12 or 16. Then server with multiple NUMA nodes less than or equals to 16 logical processors per NUMA node. So this is not a good configuration again, right? Per NUMA node, you should not have more than 8 logical processors. But still, if you have more than 1 NUMA node, say you have 2 NUMA nodes, and under each NUMA node, you have 16 processors or more than 16 processors. So your max top value in that case should be less, I mean that 16 or less than 16. That is what they are saying. But the best practice is to go again here with 4, right? If you have a VM. Server with multiple NUMA nodes greater than 16 logical processors per NUMA node, keep maxed up value at half. They are talking about keep it 8, right? Per NUMA node with max value of 16. But what my recommendation is, if you have a virtual machine, if you have, considering you have 2 NUMA nodes on that, under each NUMA node, you have 8 processors. So set the max top value to 4 only, half of the number of processors, not to 8, and see how your CX packet weight, how your thread pool weight, how your SOS scheduler weight are behaving. So how you can analyze that, I'm going to discuss that next. You are clear? Whose question was that?
Neeraj, I have a question regarding this pneumo nodes related to
Yeah,
this
tell me.
affinity mask for all the processors and what we
Okay.
have processor affinity and IO affinity.
Okay, okay. So let us talk about the affinity masking then. See here, you have processors assigned to your SQL Server. On this machine, I have 4 processors. I have assigned 4 processors to SQL Server. How I can say? I can say only by this setting. What is my affinitization? This is the GUI way to see. Affinity means how your CPU is affinitized to perform IO task and processing tasks, right? Processing tasks, when I say, it's completely related to computing tasks, right? It's not IO task. So for example, when you are performing, right, select a star from a table. So it involves only read operation, right? So it's IO intensive. So again, in order to read the record or the rows from the table, it needs CPU time. When you perform an update statement, right? So you specify set, right? Column name and some value there. You also compute something like salary plus salary multiplied by 0.01% if you want to give some increment, right? So that comes under computation. When you do a sort by, when you do sorting by specifying the order by clause, right? When you are filtering some records there, right? That comes under computation. When you are computing something, calculating something, that is computing. So, or some sorting is going on during the rebuild index job, right? Or when you are sorting a result set using the order by or group by clause, right? So that comes under computation. So basically, SQL Server uh, performs your 2 tasks. One is computation and another is IO operations, right? So how your CPUs are uh, affinitized or bonded, bounded to the operations, compute operations and IO operations, that these two settings say. Automatically set processes affinity mask for all processes, that is for computation, and automatically set IO affinity mask for all processes. These two are automatic, right? But we can specify it in manual fashion as well, right? We can decide, if I know that my SQL Server is IO intensive, not it compute intensive, right? So I can assign 3 processors to IO affinity, and I can assign only 1 processor for the processor affinity, right? I can do that. But usually we leave it to default. Let SQL Server manage it, and that is the best practice. So IO affinity comes in picture in two scenarios. The first scenario is that when you have multiple instances installed on a SQL Server. So say, for example, you have 16 processors on your VM, and you have installed 4 SQL instances, right? So how many processors you want to allocate to each of the, each of the instance, right? So you know that a particular instance is not too much transiently loaded, or it has less load, so you can assign less number of processors there, right? And if any instance is pretty much transiently loaded, or workload is higher, you can assign more processors there. So in that case, this affinity masking of processors comes in picture. That is the first thing. Second scenario is that if your application and SQL Server both are hosted on same VM, right? Then you should not allow SQL Server to use processors automatically. It will consume all processors when workload will high, and application and operating system, not operating system, especially application, will start to suffer from the crisis of CPU time, right? application will start to starve for CPU time. That is the problem, right? So there, what you have to do, if you know that application is also hosted on my VM, so in that case, you leave at least 1 to 3 processors, one to 2 processors for your application. You assign only, uh, uh, I mean that you assign all processors to SQL Server and leave a few, at least 2 processors for your application. But if your application server is more, workloaded, highly workloaded, higher workloaded than your SQL Server, in that case, you will have to leave more processors for your application. So affinity masking, right, comes in picture to set in these 2 scenarios. This is the GUI way, and the command way to check is that first you have to check it through sp configure. So sp configure gives you all the parameters, server level parameters settings listing here, and you have affinity IO mask, affinity mask, affinity 64 IO mask, and affinity 64 mask. So affinity mask, this parameter is applicable for processors for up to 32 processors. If you have more than 32 processors, then in that case, you will have to use this parameter to specify the affinity masking bits. I'm going to explain it more. Affinity mask 64, you will use it if you have more than 32 processors. Then the same is true for this. If you have more than 30, if you have 32 processors, go with affinity IO mask to set the affinity mask bit or affinity masking to perform affinity masking for processors. And the same is true here for IO, right? If you have more than 32, go with this affinity 64 IO masking. What is the value right now? The value right now is here. Configured value is 000, right? How to change it? That is the question, how we can do that. So I have 4 processors here, and I want to assign only 3 processors to SQL Server and leave 1 processor for my applications and say operating system completely, right? So how I can define this? So sp configure and copy this affinity mask here. Sorry, Control Z, affinity mask. And then you will have to specify your affinity mask. So for 3 processors, what should be my value? Let us calculate it. So put 7, put 8 zeros. First make a pattern of 8 bits with zeros. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros are here, right? Now I want my 3 processors to be assigned to SQL Server, right? So I will make these 3 bits as 1, 1, 1, 1, right? This is the binary value. Now change it into decimal. So 1 into 2 to the power 2, that is 4. 1 into 2 to the power 1, that is 2. 4, 2, 6, and 1 into 2 to the power 0, that will become 1. 2 to the power 0 is 1, so 1 multiplied by 1 equals to 1. This is binary mathematics, right? So total value is 7 here. Who asked this question?
Yeah, Chandrasekhar here.
Chandrasekhar. So Chandrasekhar, you are getting it? What I am doing?
Yeah, I'm getting.
Yeah. So I have specified the value for affinity masking 7 here. Let us confirm it through GUI right now. What is the value? Let us do it automatic. Right. It is set to automatic now. Let us check it now by refreshing this value. What is this? Under processors, it is set to automatic, right? So everything is blank here, right? You don't see that we have affinitized anything. We leave it to automatic, right? Now, when I will execute this, so 3 processors will be assigned to SQL Server performing, processing tasks in this case. So let's execute it. and do, after making any change on server level configuration, you have to execute the reconfigure command, isn't it? Reconfigure. So just execute it, and now let us refresh and check this. So you will see that 3 processes have been affinitized to CPU for performing processing tasks. Processes automatically set IO affinity for all processes. This is automatic. We didn't play with this. We played the first option. So come here and you will see 3 processors, CPU ID 0, 1, and 2 are affinitized to CPU. You got the answer of your Srinivas Chandrasekhar?
Yeah, Neeraj, thank you. And in this case, when we are allowing automatic set for IO affinity, is that mean for all IO operation, it can utilize all 4 CPUs?
When CPU will be free, it can utilize. Otherwise, okay, only one is free, it will have to use that.
We are restricting only for the compute operation. This 3
Yes.
processor restriction is only for compute operation.
Yes, yes, yes. Right? That's good. So from where you have joined, Chandrasekhar?
I'm from Bangalore.
Okay, it's a good question. I was not supposed to cover this topic today, but since you asked, you know, I just covered it. But it's a good question, right? Any other question, guys? So my sessions are always interactive, whether it is demonstration or whether it is live class, real class. My sessions are always, you know, interactive. I don't prefer to put all on mute. I don't want to be a single speaker on the stage. I want your participation also. You all are working guys here. You all are, you know, experienced person. So you can have good questions. Brooke, you there in the session?
Yep.
Do you have any question, Brooke? I don't see me. Okay. Thipa, you have also joined. Thipa ready?
Just 20 minutes less.
Oh, I was checking that whether Thipa is a new Thipa. I think this is
No,
old.
hold on.
This is old Thipa, right? Okay, okay, that's good. Data warehousing environment, max top setting. Yes. For data warehousing environment, whatever recommendation was there, I shown you that you should follow. That you should follow. Okay, so now let us enter into, I think that we have covered max degree of parallelism, and is this Siva also old one or a new one? Shiva, can you hear me? Hello, Shiva. The old Shiva is, I think, SHIVA. is a new one. Okay. Hmm. The flow is broken. What I was supposed to cover. We have to cover a lot. Okay. So let us try to discuss about the approach you should follow in order to troubleshoot high CPU utilization issue. Now you already have a good base of who is pinging. Just a minute, guys. Okay. So now you have a good base of Sql Os, scheduling algorithms, schedulers, CPU affinity, max drop setting, and cross threshold for setting. Everything you understand it now better, right? So I think the platform that I wanted to prepare is ready now to go ahead and talk about the troubleshooting approach for high CPU utilization issue, right? So what should you look for first? You must determine whether the CPU is being utilized by maximum CPU is being utilized by operating system or SQL Server or any other application. On most of the SQL Server box, you don't have other applications installed, but anyway, you must check that whether CPU is being utilized by any other applications as well, right? So I would prefer that you start your troubleshooting with these three counters in performance monitor, right? Leave about these. These are for deeper analysis. Leave about these right now. Just talk about these three, right? What you have written is a task manager processes. These are not task manager processes, right? You should not believe on task manager processes. That is a poor practice, I would say. People usually go there and see that how much my SQL Server is, utilizing, or how much my uh, any application is utilizing. That is not a good practice, right? As an expert DBA, you should not rely on task manager that someone pinged here. Most of the people do this, but I would never suggest to rely on the task manager where you see the utilization of CPU by different processes, right? You should not rely on that, right? So here I can see service host diagnostic policy is utilizing a lot of processor here, right? Right now, it is utilizing a lot of processors. Now I will show you how I can determine that. So open your task manager, performance monitor by typing perfmon. Perfmon exe is the tool for, is the utility for, is the executable for this performance monitor, perfmon. Once you type this, performance monitor will appear here, or even you can run perfmon.exe. So we have performance monitor here. Click on here, performance monitor. All right, first uncheck this, whatever is selected, uncheck it. Right click on add counters and look for processor, which will come by default here. It's not coming by default. Yes, processor is the default, right? Expand this. Under this, first select percent privilege time. This and select total or all instances, right? This privilege time says you that how much of CPU percentage is being utilized by operating system background processes and its device drivers, right? So let us select it and click on add. Next is under processor, you have user time. This specifies that how much percentage of your CPU is being utilized by all applications that are installed on the server. So let us add it. The next counter of interest is available under process object. So look for process object. Here is your process object. Where it gone? Process object. Click here and under process select user time, and under user time, when you will select user time, you will see a lot of process names. So SQL Server process, SQL Server runs, SQL Server database engine runs as a process on operating system, on Windows operating system, and that process is SQL Server .exe. So look for SQL Server here. Is it here? SQL isn't. This is here. So this contains of 8 characters, SQL SERVR, not ER, right? When SQL Server was developed, so this exe was named to 8 characters. Someone asked this question to one of the Microsoft guy, Rob, right? I was also surprised that why ER is not here. SQL Server VR is here. So at that time, the naming convention of file name in DOS was limited to 8 characters for primary part. So this is your primary file name in server.exe. Your file name consists of 2 parts, primary part and secondary part. So secondary part was a naming convention of 3 characters, or either exe, com, or batch. These are the 3 executable files in your DOS environment, right? In Windows environment, MSI is also your executable file, right? But in DOS environment, .bat, .com, on .exe, these 3 are the executable files. So it was limited to only 8 characters. That's why you see SQL SRVR, not SER, isn't it? SCRVR, not VER. Anyway, click on add, select it, and I think that we have captured this all. So click OK. Now here you have the graphical way, and you will have to look for the average value for each. So click on each, right? And this is the user time you have captured under process object. So it shows the utilization of CPU by SQL Server. What is the utilization? The utilization right now is 0%. Nothing is happening in SQL Server. Then come to the privilege time. Your operating system utilization of SQL Server is 33 percent average, right? And so 33% on average is CPU utilization is by operating system itself. And here utilization by all application, list of the application that we are running here, such as Zoom, Chrome, Word, PowerPoint, etc. and etc. They are consuming only 15%, right? So I can say that my highest consumer is operating system itself, right? Now you can go to the task manager. From here you determine and go to the task manager and then see that which process is consuming my most of the CPU time. So here I see that service.host diagnostic policy is consuming my most of the CPU time, or this is the highest consumer, right? I cannot do anything with this. It is a must, right, to run, or I can contact to Windows administrator or VMware administrator, right? So many of the times, high CPU utilization, against high CPU utilization, a ticket is generated, and that is, if it is a SQL server, it is assigned to, directly assigned to DBH, right? So don't be panic, right? This should be your first approach to check whether the CPU is being consumed maximum by operating system or by SQL Server, right? If it is being consumed maximum by operating system, simply pass this ticket to your Windows team, right? Or VMware team, or whichever team is looking for system, I mean that Windows servers, right? Now, if that is not the case, and you see that your maximum utilization of SQL Server is under this process user time, right? Where your application is SQL Server, then you have to start to analyze your weights, CPU weights, how CPU weights are going on. But before going to the CPU weights, check for the max stop value, right? And the cost threshold parallelism value. In many of the environment, DBAs are not allowed to play with the set value, right? Or it is said that max stop value and cost threshold of parallelism value, if you are going to change, a change ticket with a proper justification, with a complete RCA or proper reason must be there, right? So you cannot change that on the fly. And I also would suggest not to change on the fly, right? If any standard is defined. But if any standard is not defined, you are allowed to play with or tweak with that setting. You do that. Then your next task is to analyze the weights, right? So now I am entering into that part. Okay, I forgot to tell you one thing. Here you have to go on each of the counter, and then you have to check for the average value, right? It's better you switch yourself to the report mode. So from line graph, you can go to report, right? And in the report, you can easily find the privilege time. That is the percentage of CPU being utilized by your operating system and its background processes and device drivers. The user time, that is the CPU utilization in percentage by all applications, and the CPU utilization by SQL Server. You can see here. Any question here?
Yeah, Neeraj, like I just sent one screenshot to you, your email.
Let me check. What is taking time? Yes, tell me.
Yeah, I mean, basically, like we are, I mean, this is one of the server, and always I see, and this is dedicated for SQL, and I mean, SQL Server and the backups will go to the one of the shared drive, and I always see that processor utilization, okay, the blue one is more than the SQL utilization.
Blue
So,
one is related to what?
yeah, that is the entire processor utilization.
No, blue one is what? Privileged utilization is what? Uh, this is what color?
Yeah, that is also, I mean, lighter color of blue.
I think that is in the line. in the graph.
Yellow is for SQL Server, right?
Correct. Yes.
And this is for privileged utilization, means utilization by operating system, background processes, right, and device drivers. So when I say operating system background processes, that refers to operating system kernel processes, right? So how much it is cooperating in this graph that you will have to identify.
So
This line is
the
here. This one.
yeah, yes,
Small,
correct.
small,
Yes,
small, small, right?
yeah,
So it's
yes.
low. It's low.
But the processor utilization here, the first one, if you see that blue,
That is a blend line, sir. Blend blue lines. That is processor
okay.
utilization.
Mm-hmm.
And the last year we are seeing 0%. That is privileged utilization.
Oh, from which tool you have got this?
I mean, this is a performance baseline report from Microsoft. One of the engineers like they developed, and we were using that tool to
So
monitor the SQL instance.
what is consuming the CPU that is not revealed here, right?
Correct. So with my question here is like the processor utilization is more than SQL Server utilization.
Yeah. So which component is consuming? If it is this legend here is saying privileged utilization, it is somewhat black lines. So black line I see that is very low, right?
Yeah.
And SQL utilization sometimes it is high, but overall processors utilization is almost most of the time it is near about 80%, right? Or more
Yeah.
than 70%. So I think that something is missing here. Some more component is there that is consuming, right? So if you analyze the way I have told you in the performance manager, right, you will get the adject picture.
Okay. Yep.
Right, you will get the exact picture the way I have analyzed here in this way. You do that.
Okay.
Now let us start to analyze the weights. So once we confirm that SQL Server is utilizing my maximum CPU time, right, then we have to analyze the weights, right? So sys.os.dm wait stats, what is wrong? Wait time. And rather I will go with wait time in MS. That is total waiting time. Is it coming? Ordered by wait time in MS. Why it's not coming? Select a start from sys.os dm wait stats. Let me rewrite it. Select start from sys.dm underscore os underscore wait stats. Order by, sorry. Wait time MS. Now it is coming. Should be in descending order. So if you execute only this part of the query, you will not have relevant result that you are looking for. We are interested to look for the weights which have highest waiting time, total waiting time for what I'm going to discuss after this output. So this gives me the information with these columns: wait type, waiting task count, wait time MS, max wait time MS, and signal wait time MS, right? Here, sorry. These are your weights, right? And the data that you see under different columns are your stats. This is what Microsoft says weights and stats. Weights and statistics. So this column gives me information about the weights that exist in SQL Server. So almost every weight will exist, either with value 0 or with some value. But whatever the weights are there in SQL Server, I see 921 weights are here, right? They will appear in the result set. This result set is not meaningful for me because it does not give me the list of weights with highest waiting task count or highest waiting time, highest total waiting time, or highest max waiting time, or highest single wait time MS. So what I will do, I will sort this output on the wait time MS column. That is the total wait time. I am telling you what is the total wait time, and I will sort it in descending order. So let us execute it. It got executed here. I sorted this output on wait time MS. What is this? Let us try to understand. So this wait time MS, where was that? This wait time MS is the time that a thread waits in the waiter list of the queue, then the time it took to switch from waiter list to runnable queue, and then the time it took from switch from runnable to running state. So up to this time, this is the total wait time, right? And that is captured under wait time MS. So I sorted my output on this. There are some wait types which are related to system events, and we don't have control on that. So I'm not looking on that. We cannot even tweak that. We cannot tune those. I am interested when I am troubleshooting my CPU. I am interested for 3-4 weights, right? One weight is CX packet. Another weight is SOS scheduler yield, and third weight is thread pool. And the fourth weight, if we go more deeply, we can consider about page IO latch weight in exclusive mode. Just a minute. So let us find those weights here. It is hard to find. Well, let us try to find, otherwise I will write query for that. So lazy writer, if lazy writer is in sleeping state, lazy writer slip. So lazy writer slip, I'm telling you, these are related to IO weights, right? Lazy writer slip and write log, these are related to your IO weights. And how to analyze those weights, I'm going to discuss this. So you will have the clue. You can analyze after that. Thread pool weight, I see one of the weight here. Let us discuss this first. What is thread pool weight? How it is related to high CPU utilization, right? Or sometimes when queries are timing out, you will see high weight for thread pool. Thread pool weight denotes thread pool starvation in SQL Server. What does it mean? You have a fixed number of workers. I mean that worker threads available in SQL Server. I have 4 processors. I have seen 512 worker threads are available against 4 logical processors.
For 4 logical processors, I have 4 schedulers. Under 4 schedulers, I have 512 workers available. Say, for example, there are 2 cases. One case is that if my workload is too high, a lot of users are connecting to SQL Server and a lot of queries are coming, my workload is too high. In that case, there may be a crisis of worker threads. In that case, this thread pool will have a very high value against waiting task count. Another case is that some processes in SQL Server, some queries in SQL Server are monopolizing worker threads. They are not freeing up those threads, right? So for that, threads are not available for new queries, right? That may be the case. So both cases can give birth to thread pool starvation. So I will look for thread pool starvation as well. Now, how you can analyze the weight you have found, statistics you have, on the basis of the statistics, how you can say that whether thread pool is a problematic area, thread pool weight is a problematic area or not. So idea is very simple. Waiting task count is this, total wait time is this, right? What you have to do, you have to divide the total wait time by the total number of waiting task count against each of the wait that you are analyzing. Divide it. And if you see that this value goes beyond 80 milliseconds or 70 to 80 milliseconds, that is your problematic area. This wait can be a problem, right? This wait can be a problem. If it is below that, I'm talking about milliseconds, not of seconds. If it is below 80 milliseconds or 70 milliseconds, we are fine, right? Let us look for the next wait. I am looking for CX packet and SOS scheduler yield. So it's very hard to find. Let us rewrite the query to find that wait. We can change the query where wait type like percent CX packet percent single quote. Let us run this query. We have this also here. So CX packet is actually not an indication of the CPU issue. Rather, it's an indication or you know, the way to find how parallelism is occurring within SQL Server, right? So if the waiting task count against CX packet is high, it means that on my SQL Server, parallelism is going at high rate. My many queries are executing using parallelism, right? So again, the concept is similar here. So you divide the total wait time by your waiting task count, right? And see if this value is more than 80 or 70 milliseconds. So it is again low. If I want to increase this, right? So if I will reduce my max stop value from 4 to 2, certainly, you know, no, in that case, CX packet will be not high. Okay. So if you see that your CX packet is very high, right? What you can do, you can reduce the max drop value. That is what the practice says. If your CX packet value is not high, don't touch the max drop value, right? Or the cost threshold for parallelism value. Next wait type is your SOS scheduler Let us execute only this. It will capture that. Assured settler yield. So this is my total waiting task count. This is my total wait time. So I will divide my total wait time by total waiting task count, and even it will be 0 only, I think. It means that my no task, waited for the assignment of CPU scheduler, assignment of CPU by the schedulers, right? So by this analysis, I can say that my SQL Server is not suffering from CPU pressure. But if these weights are high, the the analysis that I did against the statistics for each of the weight, if the value I get high, more than 80 milliseconds, right, then my next task begins to check for few things. Check for first, now the query by long running queries, right, by their total execution time, or by the core execution time that is known as worker time, right? So for that, what I will do, this we have done. Also, for the, if you see the thread full value is high, right, you can check for the task count against your settlers, right? So settler ID up to 255 is considered as user settlers, right? You can have 256 processes for a SQL Server. That's why settler ID can be up to 0 to 225. Now I will check for the settler ID, each settler ID, and under that, how many current task count are there, and then how many tasks are in runnable state, right? So if I see a high value against the runnable task count, right, it means that it denotes CPU pressure. It denotes CPU pressure because the worker is assigned, but it is waiting for the assignment of quantum, because CPU quantum is not free. That's why I will see a high value under the runnable task count, right? Then your next task is to find the queries by total worker time. So what is total worker time? Anybody is having idea? Worker time is that when the query was assigned to a worker, then under that worker, how much time it took to execute, right? That is your total worker time. So total worker time denotes the core execution time of a query. It does not include your pass time, compile time, and plan generation time of that query. The time that was taken for the parsing, compilation, and optimization of that query will be not included under the worker time, right? Worker time denotes your core execution time. That when a thread was assigned to, or the query was assigned to the worker, after that, how much time it took, right? So let us execute this and try to find it out. So there are different statements here. Those are appearing. These all, I guess, are system related queries, SQL Server internal queries, right? So in order to find that, I will have to, execute some queries that I'm not able to execute now. So I'm just showing you the steps that in which manner you should go. So now you find that there is a query, user query, which is appearing as the top consuming queries, right? So one thing you have to check for, first check for the execution count, that how many times this query was executed. And after that, you come to your, there are many information in this: total worker time in MS, right? Then average worker time. So total worker time is 8,998 minutes. If you divide this by 14, you will get the average worker time, right? That is the total 14 times it was executed. So if you divide it by 14, you get the average worker time in MS for that query. Then how many how many logical reads have been performed against that query, how many, so that is again the average. If you divide it by 14, you get the average. What was the elapsed time? Elapsed time is related to your pass time, compile time, and execution time, these three themes. But worker time is only related to the core execution of the query, right? And this gives you all the information. So anyway, you got the query, you got the plan here, right? So you go to the plan for that query, and after that you must have very good understanding on that. So try to first thing find in the plan that whether it is reporting any missing indexes, right? Try to find that missing index. Try to create that missing index. That is the first thing. Second thing, try to find that which indexes are being indexed, being scanned or seek, right? And try to find, your next task is to check for the fragmentation level against those indexes, right? If fragmentation level is high, then what you have to do, rebuild that index in the online fashion, right? If the fragmentation level is below 30%, try to reorganize that index, right? This is what you have to do. This is the way to troubleshoot your CPU, right? Once you got the query, right, you do that. So the next is common causes of high CPU utilization uses. I'm not going to discuss this, but one thing I would tell, that whatever the common factor or common causes you see here for high CPU utilization issue, those are also performance killers: missing indexed, outdated statistics, non-chargeable predicates or conditions, implicit conversion, bad parameter sniffing, adopt non-parameterized queries, inappropriate parallelism, right? These all are related to your performance killers as well. Let us see the list of performance killers here. You see the list of performance killers: missing indexes, stale statistics, implicit conversion, right? Non-chargeable conditions, bad parameter sniffing. These all are the things appearing here, right? So guys, I'm done for today. I think if you have any question, feel free to ask. And let me reiterate it again that we are starting this batch from 7th of November, right? The class mode is online, as we are discussing here. Duration is of 6 weekends, 3 hours on each Saturday and Sunday. Timing will be 7 p.m. to 10 p.m. IST. In US hour, it will be 9:30 to 12:30 p.m. Course fee is 12K in INR, and you will have to pay as a down payment $180 in US, 180 in US dollars. That is the course fee. If anyone is from US, you have to convert that $180 into rupees, and you have to deposit on the account. Every class recording after the class will be shared with you for the download. You can download that. Documents that are used for the training will be shared with all of you. There are only 10 seats, right? So when the seats will be filled and anybody is coming, he or she will be not entertained in this batch. Those who are interested in this course, right, they should reply over mail, or here is my, number, phone number. You can call me, or this is my WhatsApp number also. You can ping me, right? I will send you my bank account details. I have Paytm number also. I will send you both, right? I do not use Google Pay or any other methods. I have only 2 methods. So you will have to deposit the payment before 7th of November. then only I will be able to send you invite for the classes. This is all from me, guys. If you have any question, feel free to ask.
Neeraj, Avinash here.
Yeah, Avinash, tell me.
Like yesterday we discussed like you have the batches which is starting in the month of November, right, or December. For the another course you discussed, right? That was the another job batch is going on. I think I already.
Or that will be started in December.
So I was about to discuss like, is there any courses like for Azure or something you're taking up?
Yeah. I will start Azure SQL DBA batch in December. It will be Azure SQL DBA batch.
Okay. What will be the date? Approximate means
Sir, we are
any
missing your
tentative
voice.
Maybe in the first week.
first week
First
of
week.
December.
Yes.
Okay. Thank you.
Anyone else is having any other question? Okay, guys. So if you don't have any question, I will share this recording today or tomorrow with all of you. Right? Go through this, and along with recording, I will also share table of contents of the syllabus. You can go through that if you have interest. Right? If you want to enroll in this course, so guidelines I already told you. Just follow that. Okay. Thank you very much for your time,
Thank you.
and hope to see you again in classes.
Thank you, Neeraj.
Thank you, Neeraj.
Thank you, sir. Thank you so much.
Thank you, Neeraj. Thank you so much.